Okay, we will delve into this idea of query optimization and processing. Now, in the optimization, we have got a relational algebra, and we've got some equivalent ideas like yeah. An expression that specifies detailed evaluation is known as evaluation. For example, you can sell it to fund employees, or we can perform complete relation discard salary is greater than 500. And what would be the cost? So query optimization. Among all equivalent plans, choose one that costs the lower cost to estimate a transformation based on catalog for the number of tuples is the size of the tuple. The measurement of cost. Cost is generally measured in total lifetime for relevant query, the disk access, CPU, and everything. So typically, disk access is the predominant cost as disk transfer is very slow event, so relatively easy to estimate. So number of seeks into average seek of cost, number of blocks read into average block into average block clonal. So block read, block written, and seek, and the average. So cost for writing a block is higher than cost for reading a block. This is where data is read when written to ensure that data was successful. However, for the sake of simplicity, we transfer. So data writing is always more slower than data reading. Selection operation. Selection operation can be performed various ways. Let's discuss the algorithm. So file scan. There are search algorithms that locate retrieve records, fulfill selection condition. Linear scan. This search each block and test all records to see whether they satisfy the condition. The cost of algorithm is defined as cost of searching record satisfying condition is equal to number of blocks in a database NS. Cost for search is key attribute, average number of block transfer for locating the value of half and b by 2. Linear search can be applied regardless of selection condition or ordering of records and file availability of indices. Binary search is applicable. So we have got the linear search. The cost of algorithm is defined as cost of searching records satisfying a condition, number of blocks in a database. Linear can be applied regardless of selection. Then we have the the binary search. It is applicable when the selection is an equally comparison on the attribute of file which is authored. So cost of locating the file tuple by a binary search plus sequence of a block that contains the condition. Size here is log b2 upon average number of tuples with the same value upon block factoring number of tuple of the relation. The two values may be calculated by statistic of the database. Then we have the index scan. So I guess the first was the file scan, where we had binary search and linear search. Then we have index scan. Search algorithm that use an index are restricted because the selection condition must be on search key, primary index, and for equality hash key. It retrieves a single record in a direct way, and the cost in hash key may also be considered as a block transfer needed for finding the hash. And primary index for comparison, assuming that the relation is sorted on attributes that are being compared, then we need to locate the further satisfying condition. Cost is equal to number of block transfer to locate the value of index plus transferring all block. Equal on clustering retrieve multiple records. Then we have implementation of const function. Conjunction is basically a set of AND operation. Conjunction selective are used in index. Conjunction selected using multiple key index. Conjunction selection intersection by identifiers. Disjunction. To disjunction are used only applicable condition which are available in index. Then we have negation. Then we have sorting. So created sorted partition, merging partition. So read the first block of temporary file into buffer block. Read step 1 to 5. Select the record. All input buffer. Write the record. Then when write the disk operating system. Then we have cost analysis. It is performed according to the following. Assume that the block has total set block. Set block of temporary creation. Then we have join operation. The number of algorithms that we use to implement nested join, block tester, index join, merge join, hash join. The nested joins for each tuple in student. So if nested join, there is no outer relation and inner relation. If there is enough memory to hold one block of one relation, the number of disk access can be calculated. For each student and marks tuple that needs to be accessed. However, both or one of the relation entirely in the memory block transfer will be needed. So number of block of students per number of blocks of marks. Then we have the nested join.